Alright, welcome. This video here is going to walk you through how to write an equation to a polynomial when you're given the roots. Alright, so for starters we're going to go back to the beginning of the chapter where you had some real basic equations that you found with just two roots, which would then result in the form of a parabola. So to write the equation for this, which would have roots at 4 and 5, you'd write an equation that says y equals x minus 4 times x minus 5. Now if you were to take those two parentheses and multiply them out, you would get the standard form of the parabola, which then equals x squared minus 9x plus 20. Alright? Now pause the video just for a moment, and then just work it out in your head if you have roots at 2 and 3. Think to yourself just for a moment what the equation would be in standard form if you had the graph crossing the x-axis at 2 and 3. Alright, now the equation you would end up getting is y equals x minus 2 times x minus 3, and then the standard form of that after you FOIL it all out would then be x squared minus 5x plus 6. Alright? Now let's try and do it one last time just to make sure you got a good grasp of this of how we're putting it together, the equation. If you have roots at negative 10 and 2, what would the factored form look like first, and then what would the standard form look like? Well, hopefully, when you go through this, you're going to get the factored form at x plus 10, the opposite of this number here that you see at negative 10, and x minus 2. Those are the numbers, again, for roots that you can put in the equation and get 0 out for y. So the equation that you get in standard form then is x squared plus 8x minus 20. Now think to yourself for a moment, how can you get directly from these pair of roots to the standard form equation? What I'd like you to do next is look at all three of these examples here and see how these two numbers here, 4 and 5, help you determine the numbers that are here for the b value and the c value of the standard form of equation of a parabola. All right, because this is going to help us then find new ways to do this same process then for complex roots. Because the challenge is not these. I'm already confident you could probably find the equations of these and write them in standard form. But when they become complex roots, if you don't see the shortcut of how you're going from the real roots, or these roots that you're given here as numbers, to getting the standard form of equation. Okay, so let's now try to pause the video, think of a short way you could get from these answers here to this answer over here. Alright, welcome back. Hopefully you figured out then that when you did this, if you look at these pairs of roots, the number 8 came simply by adding these two together. The number 5 that you see here, not so much the operation in front of it, but the number 5 came from by adding those two together, and the 4 and 5 created the 9. Now why is it that some of these are negative and some of them are positive? Well, simply it's just the opposite of whatever you get when you add them together. So if you add 4 and 5 together, you get 9. So you should have a negative 9 in the equation when you write it in standard form. Same thing with the 2 and the 3. You add those together, you get a 5, but in the actual standard form it becomes negative. And last of all, you got a negative 8 or a positive 8 because when you add negative 10 and positive 2 together, you get negative 8. But when you write the equation, you should write it as positive 8. Now, the next thing that you might be asking is why is it opposite? Well, the reason is because when you wrote the roots in here, you switched it to write the equation right away. When you took the opposite of positive 4, you did the opposite here. In the root that you have here at 5, you took the opposite of that to make it x minus 5 as your two parentheses. All right? So in other words, then when we go through this, you're going to find that you have the sum of the roots times x, and you always want to make sure you're taking the opposite of those values. Okay? Then the next part is, where do this 20, the 6, and the negative 20 come from? Well, again, if you multiply these numbers together, these numbers, when you multiply them together, creates the c value. So simply, whatever it is, you just add the product of those roots, and then you get your answer. So what I'd like to do now is to try and do this question on your own. If you have complex roots, what would that answer look like? Pause the video and see how you can do on those, and then we'll get back to you and go through the solution. All right? Now we're back. Hopefully you got a chance to work through this problem. Following the format of what we do, we simply write x squared plus the sum of the roots. If you add these together, the i's are going to cancel, which then would be y equals x squared minus 4, or minus 4x. And then if you were to multiply those together, using the concept of what you did with conjugates, where you're going to take a squared plus b squared, where a is 2 and b is 1, the number in front of that I there that you see there is a 1. So then you're basically taking 4 plus 1 to get 5. And that would then be the equation that you get that makes these roots that are complex conjugates or complex roots for the parabola that doesn't touch the x-axis. So when you see this right here, then simply whenever you have two conjugates, the simple way to multiply two conjugates together again is to take the a squared and the b squared and add them together to create this c value that you see here. All right, so the next one, I want you to try this on your own, see if you can come up with the answer on your own first. So pause the video, see if you can create that equation as well. in the standard form. All right, here's a walkthrough of this one as well. You're going to simply just write y equals x squared, add them together. That's 3 and 3. Both two i's cancel. So then you take the opposite of 3 plus 3, which is 6. So you should have a negative 6 here, 6x, and then simply multiply those two conjugates together to get 9 plus 4, because 3 squared is 9 and 2 squared is 4. Add those together to get your c value, and that's where the 13 comes from. All right, do it one last time just to make sure you got it locked in. Try to do this one here with 3 roots now. It's a little bit of an upgrade from the previous 2 problems. You're going to be doing it with 3 roots. So now the last one here is just simply go try this out on your own, and then pause the video, and then go through and work that one out as well. And here we go. Simply you're going to write x minus 2 to get the real root here at 2. The 2 complex roots that you're going to have here, then simply add them together to get x squared minus 2x. And then by multiplying those conjugates, you got 1 squared plus 25 squared to get 26. Hopefully this activity was successful for you. So in the future, whenever you see 2 roots that you're given to you, hopefully you can now find the equation that creates those roots by simply following the format that we have up here in this blue box. Good luck, and hopefully you're successful.